Welcome to Asim Code. Hey guys. Welcome back to the channel. Hit that like button and subscribe to be part of the family. The Perceptron is a foundational machine learning algorithm used for binary classification, meaning it distinguishes between two classes, for example, positive and negative. It works by learning a decision boundary that separates the two classes. During training, the Perceptron adjusts its weights and bias based on the errors it makes. The model starts with random weights, often initialized to 0, and updates them iteratively using the Perceptron learning rule. For each training sample, it computes a weighted sum of the input features, applies a threshold, usually 0, and makes a prediction. If the prediction is wrong, the weights and bias are adjusted to reduce the error in the next iteration. This process continues for multiple epochs, iterations over the whole dataset, until the model reaches an acceptable level of accuracy. The perceptron is simple, but its limitations, such as the inability to handle nonlinear decision boundaries, led to the development of more advanced algorithms like neural networks. Importing the NumPy library, which provides support for array manipulation and mathematical operations. Perceptron class. This class will implement the Perceptron model for binary classification. The constructor initializes the Perceptron model with key parameters. Initializes the Perceptron model. N_features, number of input features in the dataset. This determines how many weights we need, one per feature. Learning_rate, how much to adjust the weights during each update. A smaller value means more gradual learning. N_iterations, how many times we want to repeat the process of going through the entire training dataset, epochs. Initialize weights to 0. np.zeros creates an array of zeros with size and underscore features. Bias is initialized to 0. The bias helps adjust the decision boundary of the perceptron. The learning rate controls how big the steps are when updating weights. How many times we will loop through the entire dataset to train the model. The fit method is used to train the perceptron using input data, x, and labels, y. Trains the perceptron using input data x and labels y. X, 2D array, matrix, where each row is a sample, and each column is a feature. Y, 1D array of labels, either 1 or -1. These are the target values that the model tries to predict. Loop through the number of iterations epochs. Each iteration represents one complete pass through the dataset. Iterate over each sample in the dataset. Len X returns the number of samples, rows, in the feature matrix X. Step 1. Compute the dot product of the current input features X, I, and the weights, and add the bias. np dot dot, a numpy function that computes the dot product of two arrays. This gives us the linear combination of inputs. Step 2. Apply the sign function to decide the predicted class. If linear underscore output equals 0, predict 1, positive class, otherwise predict -1, negative class. Using a conditional expression to assign a class label. Step 3. If the prediction is incorrect, update the weights and bias. If the predicted label is different from the true label Y, I, we update weights. Update the weights. Increase or decrease weights based on the true label. Update the bias. Adjust the bias term to better align the decision boundary. This method makes predictions for new input samples. Predicts the labels for the input samples X. X. The input feature matrix. Each row is a sample, each column is a feature. Returns an array of predicted labels, 1 or -1. Calculate the linear output for each sample by taking the dot product of the inputs and weights plus bias. Return the predicted label, 1 if output equals 0, -1 otherwise. np.where returns an array with 1 where condition is true, -1 where false. Example usage of the perceptron. Example dataset with 2 features and 4 samples. Labels are either 1 or -1. 2D NumPy array for input features, for samples, 2 features each. Create a perceptron model for 2 input features, since X has 2 features per sample. Train the perceptron on the dataset. Make predictions on the same dataset, for simplicity, using the same data. Now run our code. Thanks for watching. Like and subscribe to see more awesome videos.